Hello everyone, let's check out this problem here, this classic multivariable calculus problem. We're going to use spherical coordinates to find the volume of the part of the ball with spherical radius A that lies between the cones phi equals pi over 6 and phi equals pi over 3. What? Let's try to figure that out. What's that all about? Okay, so here we have a ball with radius, we've been calling it spherical radius, but rho equals A is the boundary. So the ball is also, it's the boundary, the sphere, and then the interior. So it's rho less than or equal to A. And so say this point right here is A, 0, 0. Okay, so let's recall that phi is the angle. If we have a point, say here's a point, and we draw a line from that point to the origin, a line segment or a line going all the way through, but the angle of that line is phi, the angle that's formed with the z-axis. So let's just check out this piece here where it says phi equals pi over 6. So if we look at from here to here, pi over 6 is around 30, pi over 6 is exactly 30 degrees. Okay, so this point seems to have an angle of 30 degrees. But if you go over here, this angle is also 30 degrees. So it forms, as it says, it forms a cone. So all these angles, so phi equals pi over 6 consists of all the points where you have an angle of pi over 6 with the z-axis. So that in itself is a challenge to understand what the heck that means. Any questions about that? Speak up. Okay, so we're not. Oh well. So that's this cone. Okay, and then we have another one, pi over 3, which is 60 degrees, and so it's down here or something. So it has to lie within the ball and within these two cones. I mean, it was all right to draw that picture. It's not as gorgeous as maybe I'd like, but so it's the region between those two. So and in fact, this is hollowed out on the inside. Like that part inside there is hollow. So it's just the part in between those. So what we're saying is that let's write our boundaries for rho. So rho is between A and 0. And then let's write our boundaries for theta. What about theta? What are the boundaries for theta? Remember, theta is the angle formed with the x-axis. So that can go all the way around from 0 to pi. So what should I write down for theta, do you think? Yeah, 0 to 2 pi, unless it says the first quadrant octant or something like that, but it doesn't. And then phi is between pi over 3 and pi over 6. So even though I think that the drawing and the idea of that being a cone might be difficult, I feel like hopefully the integral won't be that bad. Oh well, I had this idea, maybe I'd try to improve upon this picture. So this is what I'll call E, and I have rho, theta, phi, such that they satisfy this condition. Now, the volume is equal to the double integral over E of 1 dV. That's true in general. So if you integrate the number 1, then you get over the region, you're going to find the volume. I just feel like somehow this picture looks just a little bit not as good as it could. Maybe it should be like that or something. Okay, so just go in there. Now, I have these formulas also for this spherical coordinates for x, y, z, r. R is not in spherical coordinates, but we use that sort of, it's in the background. That's, and then, but anyway, we don't have to use, it seems I don't have to use any of these except for the last one, dv. dv is rho squared sine phi d rho d phi d theta. So I'm going to integrate 1 rho squared sine phi d rho d theta d phi. So we need to include this piece here. Rho goes from 0 to a. Theta goes from 0 to 2 pi. I don't see any theta here, so we can think about that. And then pi over 6 to pi over 3 with for phi. Let me try to make it a little more neat. Okay, so rho goes from 0 to a, and then 0 to 2 pi for theta, pi over 6 to pi over 2, or pi over 3 for phi. Okay, now we have a function of rho, a function of phi, and maybe the function of theta is just 1. And these right here are constants for our bounds. So because of that, we can break this into pieces. We can go from pi over 6 to pi over 3 of our function of phi, which is sine phi. Then we can go from 0 to 2 pi of 1 d theta, and then 0 to a rho squared d rho. And it doesn't matter actually which order we put all those three in there. And then I can do what I've been doing before, which is I'll write this as A, B, and C. How am I starting on this purple? It's all right, but usually like a dark blue shows up better. Okay, so I think maybe the one well, I don't know if it's even difficult that much, but anyway, I'll do pi over 6 to pi over 3 of sine phi d phi. So let's see, how about you all? What's the antiderivative of sine phi? Did you put the negative in there? Okay, so we have cosine pi over 3. Anyway, the derivative of cosine phi is negative sine phi, and then you have the other negative, this negative out here to counter that. And then cosine pi over 6. And how do you evaluate that from, do you have the unit circle sitting in inside your head? Just, you can access it. So pi over 3 is up here. This is, x and y, but pi over 3 is up there. It's 1/3 of, here's pi. So it's 1/3 of that upper semicircle. I'm looking and I see the x coordinate should be less than the y coordinate, so that would make 1/2. Rad 3 over 2, that's the pairing. Pi over 3, this is down here at 0, we have 1, 0, so pi over 3 in terms of x is halfway there. And then pi over 6 is halfway up. So it's 1/2 for the y coordinate. Cosine is the x coordinate, sine is the y coordinate, so just a little review of this unit circle there. So cosine pi over 3 is 1/2. Cosine pi over 6 is rad 3 over 2. Again, x coordinate is cosine, y on the unit circle, and the y coordinate is sine, but we're using cosine here. So this is, I'm going to distribute the negative through and put the larger number first. All righty. I wouldn't be surprised if the book writes it like this, or someone would get a common denominator, or we have a common denominator right as a single fraction. All right, so maybe that was the one that took a little bit of time. Okay, then B, I have the integral of 1, 0 to 2 pi d theta, and that's just 1 times 2 pi minus 0. If you have a constant and you integrate the constant, you take that constant and you multiply by the length of the interval. And then C, I think the hardest part was sketching the graph, right? C, we're going to go from 0 to a rho squared d rho. So this is going to be rho to the third power over 3 from 0 to a. So this is a to the third over 3 minus 0 to the third over 3. So finally, our answer is multiplying a, b, and c. My notation's maybe not really the very best there, but still, okay. So I have rad 3 minus 1 over 2 times 2 pi times a to the third over 3. Did anybody look that up by any chance?
Yep.
How did they write it exactly?
Well, cancel the 2 and then
Oh, right.
you're left with
Yeah, Q2's cancel. So what exactly did they write down?
rad 3 minus 1 and then all over 3.
And then they put pi a cubed like that, or a cubed pi. Either way, anyway. Anyway, we got it right. I was just trying to make it look the way they did it. Okay, so, wow, that was so awesome. Or maybe not, I don't know. What do you think? So, any last comments? Yes?
So, just as like a rule of thumb, like, what should we look out for in terms of like canceling out like the trig integrals, like cosine evaluating to 0?
Oh, okay, let's talk about that after the video. Yeah. So I was talking about some shortcuts from a previous problem. Okay, everybody. How about putting a like? That'd be so cool. Or and even comment. Love to hear from you. And then the very best is to subscribe also. All right, take care, everyone. Bye.